Hi everyone. Today I'm just going to give you just a quick introduction, get you set up on the next activity that we're going to do. Yesterday we looked at ratios within 45, 45, 90 and 30, 60, 90s, and we found out that it didn't matter the side length that we picked. The ratio of things like the opposite over the hypotenuse and the opposite over the adjacent were always the same. Didn't matter what size that triangle was. So the question that I'm posing here now is that just true for just special right triangles, or does that work for any right triangles? Okay. I'm going to get you started on this activity here, ratios in any right triangles. So this is going to require GeoGebra, and the reason why is for special right triangles we knew the pattern. If we picked one side length, we knew the rest of them. Here I'm going to have you first off work on a right triangle with a 20-degree angle. Then I'm going to have you work on a right triangle with a 63-degree angle. We don't have patterns for that, so we're going to use GeoGebra to measure the sides and use those to calculate the ratios. I'm going to show you just a quick refresher here on GeoGebra on how to get things set up, and you should be able to take it from there. So I want to construct a triangle ABC, so B is the right angle, and the measure of angle A is 20 degrees. So I'm going to start off with a side. Now I need this to be a right triangle with a right angle at B. So I'm going to use my perpendicular line tool and make my right angle there. Now next, I need A to have a 20-degree angle. So I'm going to go to angle with a given measure, angle with a given size. I'll click B, then A, and this is where I would type in my 20 degrees. Now because I want to do something different than you guys, I don't want to give it away, I'm going to pick a different angle measure. You guys are going to be 20, I'm going to go with 34. Okay. Now we should see how we can complete our triangle by using a line. And we've got a triangle right there, ABC, B is the right angle, A is 34 degrees, remember yours will be different. Now what I want to do is fill out this table. I'm going to find the length of AB, and then I'm going to write down these ratios. So I'm going to go to my length tool. I'm going to measure how long each side is. AB 6.06, there's BC, there's AC. So on my, oops, not on that one, on my sheet, I'm going to write in A is 6.06. Now I'm going to find the ratio of the opposite over the hypotenuse. Which side's opposite A? 4.09. Which side is the hypotenuse? 7.31. I'm going to grab my calculator. I'm going to type in 4.09 divided by 7.31, and I got about 0.56. Now I'm going to do the adjacent over the hypotenuse. I'm going to look at this. I'm going 6.06 divided by the hypotenuse, 7.31, and I got 0.83. Then I'm going to do the opposite over the adjacent. So I'm going to do 4.09 divided by 6.06, and I get 0.67. Now you're going to do this for 3 different lengths of AB. So I just did it when AB was 6.06. What I'm now going to do is I'm going to go in, I'm going to grab this point A, and I'm going to change the length. Now AB is 9.46. All my side lengths change. I'm going to go back into this, and I'm going to write down all the new ones. So I'm going to go, okay, 9.46. And then I'm going to find all of those ratios. When you've completed this table, okay, now I'm not here, so I'm going to have your substitute sign off on this. They're going to take a look to see what's happening and sign off on that. Once you've done that, now we're switching that angle A to 63 degrees. So that means make a brand new triangle. Okay, where this angle is 63 degrees, it's still a right angle. You're going to do the same process. Then we get to the bottom. What do you notice? Why is it that way? If you notice something, if you think a pattern is evolving here or something's going on, Okay? Say what it is and then try to come up with an argument why. Okay? That argument probably should include some sketches and some proportions. Okay? That's how you're going to do that. So once this one's done, have that signed off by your substitute, okay? And you should be good to go. Other things that are going to be happening when you're done with this, I want your Safer Out problem posted onto Seesaw. I've got that set up as an activity. We're going to go picture today, no audio, just with everything that's going to be going on. When you have the Safer Out problem, take a picture of it, post it on Seesaw. There's extra Safer Out pieces of paper in the basket over there. Okay? This you are working on with partners, so just one piece of paper for two of you. Okay? Hope this goes well. A lot more to learn from this, and I'll see you later.